Will that be able to show? Maybe? Okay. All right, so in today's experiment, we're checking miscibility of liquids. So what we're going to do, we're going to put two liquids together or two solvents together and observe if they are miscible or immiscible. If you mix two samples and they are miscible, you will end up seeing a solution that does not have a separation in phases. If they are immiscible, you will see that separating into two layers. Okay, so what I'm going to do, I'm going to begin with, can you pause that please? Okay, so what I'm going to do, I'm going to start mixing the various samples and we will observe to see if they are miscible or immiscible. So I will begin with the test tube that's empty. I'll put in some amount of water. And you can see that it's a clear solution of H2O. Then I will add about the same amount of ethanol. Squeeze that in and make sure that I mix it and allow it to settle and make an observation. So when you look at that, if you see that separating into two phases, then it is immiscible. If you do not see a separation of phases, then the two samples are miscible. All right, so with that, please go ahead and make your observations.
And you said that's ethanol and water?
You can go ahead and pause it. Our next mixture will be methanol and water. Let me begin by putting in some amount of water. And I will pour in about the same amount of methanol. So here is methanol. Add in about the same amount. Make sure it's thoroughly mixed. Okay, shake it and allow it to settle, and you make your observations. All right, so with this, please go ahead and state if it is miscible or immiscible. All right, let's go to the next mixture. Again, I'm going to put it H2O. And this time I will be adding acetone. Add acetone to it. Shake it. Allow it to settle and make the observations. Our next mixture, again H2O, and this time I'm going to be adding hexanes. Okay, hexanes, what I will add to it, about the same amount. Shake it, let it settle, and take a close look. Let's get to the next. Our next will be a mixture of H2O and cyclohexane. So let me begin with H2O. Then I'm going to add in cyclohexane. It's a cyclohexane. And shake it and observe. Alright, so we will continue. The next mixture will be ethanol and methanol. Usually it doesn't matter which one you put into the test tube first. Okay, but I have ethanol. Let me go ahead and add ethanol in here. And I will add about the same amount of methanol. Shake it, let it settle, and observe. So you you should be able to report if this is miscible or immiscible. It will be ethanol and acetone. Ethanol, about the same amount of acetone. Shake it, let it settle, and make your observation. Alright, for the next, it will be a mixture of ethanol and hexane. Ethanol and hexane. I'll begin with ethanol. And I'm going to add in about the same amount of hexane. And make your observation. I'm going to give it a good shake.
And this was what mixture?
This is ethanol and hexane. Ethanol and hexane. And cyclohexane. Ethanol and cyclohexane. Let me begin by pouring in about the some amount of ethanol. I'll add in about the same amount of cyclohexane. Shake it. Give it some time. This is cloudy, so let's give it time. Okay, so that cloudiness should go away. I'll give it some time. Our next mixture will be between methanol and acetone. So I'll put in some amount of methanol. Add just about the same amount of acetone. Shake it and give it a few moments to settle. Make the observations. The next mixture, we're going to have ethanol and hexanes. Put in some amount of ethanol. Okay, that's methanol. Add about the same amount of hexanes. Shake it. Give it a few moments to settle. Next, we have methanol, and that will go with cyclohexane. Put in some amount of methanol. Add about the same amount of cyclohexane. Shake it. Give it a few moments to settle. And record your observations. When you see too much cloudiness like this, that just means that you give it a longer time to settle. Let's put it here. We'll observe it in just a few moments. So I'm getting the other stuff. Okay, so let's get to acetone. So let's make a mixture of acetone and hexanes. So let me get some amount of acetone. I'll add about the same amount of hexanes. Shake it and make your observations. Okay, next I'm going to add in some amount of acetone. I'll add about the same amount of hexane. This is cyclohexane. Add about the same amount of cyclohexane to acetone. Shake it. Let it settle and also. Okay, go ahead and record it. Our last mixture for part B is going to be between hexane, okay, hexanes and cyclohexanes. I'll put about the same amounts. Shake it. Make your observations and record. Alright, so for the next part of our today's experiment, which is part C, we have 4 compounds and we want to figure out which of those compounds will melt first, which will melt second, third, and fourth. The one that takes the longest time to melt will have the strongest intermolecular forces. The one that melts first has the weakest intermolecular forces. So through this procedure, we're going to verify which of these compounds will have the strongest intermolecular forces, which have the weakest. That's what we'll have to do here. So what do we have? We have naphthalene, we have iodine, we have sucrose, and we have sodium chloride. I have covered the top of a hot plate with aluminum foil. I will place a small amount of each sample. Make sure I know which position is which sample so that I can track that. So let me begin by placing naphthalene. Okay, take just a few crystals. We don't need much. And place it on its own spot. Okay. Make sure you clean the spatula before you move to the next sample. Take a few crystals. This time we have iodine here. Take a few grains on its own spot. Please make sure they are far apart. They shouldn't touch each other so that they are not interfering with the action of each. Clean up again. Take the next sample, this time sucrose. Take a few grains or a small amount of the powder. Place on its own spot. And the fourth sample to place here is sodium chloride, which is table salt. A small amount of it in its own position. Now that we have all 4 samples on the hot plate, we will turn on the heat. Alright, it's already plugged in. I will turn on the heat and we observe. We will monitor it closely and record the one that melts first, second, third, and we will know the last that melts. So let me go ahead and turn on the heat. So we'll have to give it some time because it will take a while for this hot plate to heat up and to get to a temperature that this heat will begin to melt. So by now you should see something happening on at least one of the samples. And the reason I have this knuckle close to it is so that any fumes that are given out should be sucked out of the bowl. take a look at this. So you come close, please take a look. The one that has melted, indicated as the first to have melted. That means it was not that time subliming, okay? It was subliming. So it is basically subliming. The other two seem to be taking much longer. So what I will do, I'll go ahead and increase the heat. Alright, so the next is in the process. You can see that sucrose is in the process of melting now.